Alright, so what I'm going to do is I'm going to make a couple of things here that some for customers and some for myself. And I need to make some brackets to hold my installation up in the garage that I'm in. So I'm going to do that right now. And this, we're going to plasma cut this out. And so this is just going to be a quick run through of me doing that. So yeah. I'm going to start with the square. These are going to be roughly 12 inches long by 2.5 inches tall. And this is VCarve Pro, by the way. It's a Vectric software. It's a made for CNC routers, which I have, but you can also create DXFs, which you take the DXF and put it into the software for the plasma cutter, and that's what they use to generate the toolpath. So that's why I'm doing it here. It's a lot easier than using Fusion 360 for this kind of stuff. So that's why I just choose to use this. So I'm going to close out of this, and I can round these edges, which I probably will do. So we'll just go back into the box, and we will create a radial external edge, and we'll put this as a 0.125 radius. And now, as you see right here, it put a radius on it on all four corners. So we'll hit apply, close. So now we got our square. So basically, in this garage that I'm in, we have metal bars. It's a metal building, and these metal bars are joists that hold the ceiling up, and in between the bars are 2-inch thick insulation pink foam, and they're falling down. So I'm going to make these little brackets that I'm going to put 2 holes in the center, so I can run self-tapping screws up into the bar to hold these insulation panels up so they don't keep falling on my head. So that's easy to do. So this has a snap feature, and I can tell where center's at. So right there's center. And if you come over here, right there's center. So I'm going to put 2 circles right there. And I'm going to close that out. And these circles, you got the freedom to move around some things on here with your arrows. And I'm just eyeballing these. There's no rhyme or reason to what I'm doing. I just need holes. So the size is 0.22. For the screw I'm going to be using, that might be good, but I'm going to make them 0.2. I can always draw them out. Always better to go small. Okay. And boom. There we go. Now I got, within what, 2 minutes, I got a bracket. So now I'm going to save this and call this insulation bracket. Okay, so now that I got that saved, we're just going to take this, I'm going to file, export DXF, and as you can see, I got a bunch of stuff in here. This is for my plasma cutter DXF folder, so we're just going to save that in there. So now we're done with that, and I'm going to open up SheetCam, and this is a software for putting a toolpath to my plasma cutter. Let's see here. This is going to be made out of stainless steel. So first we're going to file, import drawing, click on the installation bracket, and everything is the way these are presets that I have saved. Right there's my bracket. So Now I need to make a library because I've never cut stainless steel on this machine yet. This is just 16 gauge stainless steel, and I go by the plasma cutter that I have, their recommended settings, just because it's easier that way. Then I can fine tune it from there. And so we're going to go over here, create a new plasma cutting tool, and so the path rules, kerf width. I'm using a 1.0 nozzle, 1 millimeter nozzle. So all this stuff corresponds with that. But I need to change, more importantly, the feed rate, pierce delay, and trying to think of what else I need to change on here. The other settings I have to do on the actual plasma cutter itself. So with that being said, we need to do 82 inches per minute, according to my book, at 30 amps and 55 psi air pressure. So the pierce delay, I'm going to leave that just to see what it does, and we're going to name this cut 60, the name of my plasma cutter. 16 gauge stainless steel 1.0 nozzle. So now we got all that, and we hit OK. Now you see, put it over here. So come down here, and this is where you put the tool paths in. So I'm going to select stainless steel one, and we're going to go offside outset layer. That's going to select the layer on there and put OK. So as you see now, there it is, and right here it is. So now this is ready to be cut. So we're going to come up here, and this is going to go to the G code. It's a TAP file, and we're going to save. And it says that everything was completed and good. So we'll hit OK. If there was an error, there would be a message up here saying, hey, this is too small, or this couldn't cut this all the way because of this. But everything's good on this one. So now I can close this out. And I do want to save. No, I don't want to save that, but I do want to save the default tool set. So that now we're going into the fire control. This is where the software that controls the plasma cutter. We have a Langmuir Crossfire Pro, and bada bing, bada boom. So we'll plug this in, the USB to the control panel, and you'll see everything come to life. Bam. Now we just load the program, and we'll click on that, open, and bam, right there is our bracket. And if you look down here, that is the width and height of our bracket. And as you can tell, it's slightly bigger because the tool path knows that we're plasma cutting it, and it knows the kerf of the laser beam, so it makes it bigger so that way your part comes out more accurate. So now we have that, and I'm going to show you on the plasma cutter the rest. Alright, so here we are at the plasma cutter. So I'm going to jog the machine over to where we need to be at. and we're going to cut just one bracket out. I just want to see what the settings and everything are going to be like, so we're just going to do one test cut, I guess you can say. So I'm going to go over here to the computer, and I'm going to jog the machine over. And too far. I'll lower the Z down a little bit so I can get it better. Whoop. Oh boy. Try and get right on the corner so I can do a 1/8 of a step. And we gotta go up because we got those little cutouts on the bottom there, so we'll just go up a little bit more. And that'll be good. So I can 0, and we're ready to cut. Put my sunglasses on. Gotta look cool when you're doing this. And we're going to fire the bad boy up. There you have it. So now that piece is cut out. Not too bad. Not too bad at all, if I say so myself. If I can get it out. It's a little warm. But, so I can see barely any dross on the back, but I can live with that. That looks good. So I think we're just going to run with it. Alright, so now with that being done, let me walk up the ladder here and show you guys what it looks like done. See if I can do this without killing myself. But so that right there, 2 holes in the center. What it does. So, just to show you, you know, some of the simple things that we can do.